The lengths of a large stock of titanium rods follow a normal distribution with a mean of 440 mm and a standard deviation of 1 millimeter. What is the percentage of rod whose length lie between 438 millimeter and 441 millimeter? Let x be the generalized normal random variable having mean mu and the standard deviation sigma. Okay, so this y-axis, vertical axis, represent the probability of x. Since x is generalized normal random variable, we must convert x standardized normal variable. Okay, so let's convert. If we convert x to alpha, initially we needed to find the probability of p of x that is greater than x1 and lesser than x2. Now since we are converting into standard normal form, so x is converted to alpha. Now we need to find the probability of p alpha 1 lesser than alpha 2. Okay, so now we need to find this probability. And since alpha is standardized normal random variable, so the mean must be converted to 0 and the standard deviation sigma should be 1. Now this x we are converting to alpha. This normal probability distribution in standard form, it will be p of alpha, right? Since x is the generalized normal random variable, we'll write x mu sigma and it is converted as, now new variable is alpha, that is in standardized form. So alpha and the mu should be equal to 0, standard deviation 1. So this is how we do the transformation of x to alpha. Now in the problem, the generalized mu and sigma value is given. So given data, let's write here. What we are given the mean is equal to 440 mm and standard deviation, say sigma, is equal to 1 mm. And it's also given that x1 value is 438 mm and x2 is 441 mm. Now using these data, we can calculate alpha 1 and alpha 2. So alpha 1 will be equal to, so alpha 1 will be x1 minus mu divided by sigma 1 or sigma, let's say sigma, and this will be equal to 438 minus mu, that is 440, the mean value, divided by sigma, and sigma is 1. So this value comes out to be negative 2. Now alpha 2, if we calculate, it will be x2 minus mu by sigma, and this will be equal to 441 minus 440 divided by 1, and this is 1. Now let's represent this alpha 1 and alpha 2 on the graph. Alpha 1 value is lesser than alpha, so, and it should be in the negative side, so this is alpha 1 and this will be alpha 2. Now let's represent this alpha 1 and alpha 2 according to our problem. So for this problem, alpha 2 is 1 and alpha 1 is minus 2. Now the probability distribution that we are interested in is p of alpha 1 lesser than alpha and lesser than alpha 2, which is p alpha, instead of alpha 1 we can write minus 2 lesser than alpha lesser than 1, and this can also be written as p1 minus p of negative 2, and this p1 and p of negative 2, this can be found from standard result, right? So the standard result we call 1 sigma limit or 2 sigma limit or 3 sigma limit. 1 sigma limit, like 1 sigma limit, if I say, now 1 sigma limit is a standard result, and the meaning is probability of finding alpha from minus 1 to 1. Okay, and this is the value of this probability is 68.27%. Now 2 sigma meaning is probability of finding alpha in between minus 2 to 2. So obviously the probability will increase, and the value is approximately 95.44%. You can also calculate these values, but it's recommended that you remember these values so that it will be easier for you to solve the problems. You can also remember the 3 sigma limit. I'm not going to write it here because it's not required in this problem. Okay, so minus 2 to 2, that means from, if I take this one, 2 sigma limit. Okay, so this is from minus 2 to plus 2, somewhere here. Okay, so since now we have these two results, 2 sigma limit and 1 sigma limit, we can find out this probability. Now the required probability for our problem is, let's write here, probability of finding alpha in between minus 2 and 1. Okay, so this can also be written as probability of finding alpha from minus 2 to 0, in between minus 2 and 0, right? Plus probability of finding alpha from 0 to 1, so 0 to 1. Now probability of finding this alpha, this is half of 2 sigma limit, so this is 1 by 2 of 2 sigma limit, right? Plus this is half of 1 sigma limit, and the probability, the value of probabilities we have, it's the standard result and we already know this, right? So let's substitute that value, half into, so 2 sigma limit value is 95.44 plus half into, and this 1 sigma limit value is 68.27. So if we calculate this, we get 81.85%. And this is the desired result, right? The probability of finding alpha in between minus 2 and 1 is 81.85%. Now let's go back to the problem. So the correct answer here is 81.85%. So option A is correct. To get detailed information on normal distribution, you can refer to the NPTEL course on normal distribution by Professor Mukesh Doble of the Department of Biotechnology at IIT Madras.